Good afternoon everyone and welcome to my YouTube channel. So here today we are going to be looking at solving of complex numbers. So we are going to be solving the values of certain complex numbers. So firstly, the thing is that whenever we have a real number, we equate it to a real. So we know to say under complex numbers we are going to equate the real part to the real part. So now, what do we mean by that? So this means to say the pure numbers that are without I, you equate them to other pure numbers that are without I. So let's say we have our, let's say we are required to find x and y. So let's say this is our a. So we have x plus iy should be equal to, we have 7 minus 4i, like that. So this one, what we are going to do is, so the real part is the one without I. So already this one will be our real, this one will be our real. So the other one, that means to say this one is our imaginary, and also the other one will be our imaginary, like that. So now, when we establish this, we are going to equate. So this x, since it is without x, it means to say x should be equal to 7. When we have this iy, so our iy should be equal to negative 4i, like that. Then dividing by I, we are going to have that our y will be equal to a negative 4. So these are our values. Let's say we have this type of an arrangement. So we are going to open the brackets. So here this is the same as there is 1 won't change anything. So this is the same as 3x minus iy. Then we have plus a 2. Then we have plus 13i should be equal to a negative 7. So we have negative 7 plus our 3i. So when we do that, what will happen is that we can now be able to group them, the real part together and the imaginary part together. So we are going to have our 3x, which is the real part. Then we are going to bring plus a 2. Then we have minus our iy. Then we have plus 13i, like that. This should be equal to negative 7 plus our 3i, like that. Then when we do that, we are going to have our 3x. So this one, so already this will be our real part. Then that means to say this one will be our imaginary. So also this one is our real. This one is our imaginary. So now with that said, we are going to equate them. So this means that our 3x plus 2 should be equal to negative 7. So taking the 2 the other side, we have our 3x should be equal to negative 7 minus 2. So we are going to have our 3x should be equal to negative 7 minus 2 gives us negative 9. We divide 3, we are going to have our x to be equal to negative 3. Then we are also going to get the imaginary part, which is our negative iy. We can even interchange them. Plus 13i should be equal to 3i, like that. So since I is common throughout, we can divide I, so that we have our, this cancels, then we are going to have negative y, then we have plus a 13 should be equal to 3. So we are going to take the 13 the other side, so we have negative y should be equal to 3. Then this one goes this side, we have minus 13, which will be our negative y should be equal to negative 10. Then we are going to divide over negative 1 to give us y is equal to positive 10. So that means we have answered. So we are advancing. Let's look at this one. Let's say this one is our C. We have our x plus iy. Then we have times our 4i should be equal to 8. So how do you solve this one? So this is the same as 4 multiplying everything. So you can even write 4i, open brackets, we have our x plus iy should be equal to 8. So this 4 times x, it gives us 4xi. Then 4i times iy, it will give us plus our 4 y, then I times I gives us I squared, which should be equal to 8. So what do we have? We have our 4xi, then we have plus our I squared is equal to negative 1. So we are going to have 4y, then I squared is negative y, should be negative 1, should be equal to 8. So we have our 4xi, then we have this times that, we have negative 4y should be equal to 8, like that. So now after reaching this stage, we are going to be equating them. Now if you look at this, we only have the real part here. We don't have the imaginary is there. It's just that the imaginary is 0i. So we are going to equate them. So equating, we are going to have our 4xi should be equal to 0i. We divide over 4i over our 4i. So this will just give us our x to be equal to 0. This means that our x is equal to 0. So the imaginary will equate it. Then let's look at our real part. We are going to have our negative 4y should be equal to 8. Then this number, what we are going to do is divide negative 4, divide negative 4. So our y value will be equal to negative 2. So already our x is equal to 0 and our y should be equal to negative 2. So let's say we have x over 1 plus I minus y over 2 minus y. So now for this problem, what we are going to do is, firstly, let's introduce how we are going to be multiplying. Let's say the conjugate, we have 1 plus I times our 1. Let's say the conjugate means you just change the sign here. We have 1 minus I. So to multiply this means that 1 is multiplying everything. So we have 1 multiplies 1 minus I. Then this I plus I multiplies everything here. That's the meaning. 1 minus I, like that. So we are going to have 1 times 1 gives us 1. 1 times I, it will give us negative I. I times 1, it will give us I. Then our I times I, this one is going to give us negative I squared. So we are going to have 1. Here we are going to have 0. Then we have minus our I squared, like that, since here it's 0. So we are going to have 1 minus I squared is our negative 1. Then we are going to have 1 plus 1, which should be equal to 2. Now, instead of doing this, what we are going to be doing for this video, we are just going to be saying, if we have 1 minus I and also 1 plus I, we are just going to multiply first number with the first number. You can do this if it's a conjugate. So we have 1 times 1. 1 times 1, it will be 1. Then last number with the last number, we have negative I times this I. This one will give us 1 minus I squared, which will be 1 minus I squared is equal to negative 1. So we have 1 plus 1, which should be equal to a 2, like that. So with that said, let us be able to answer this. We are going to be using the conjugates. So already we are going to say x over 1 plus I. So here we are going to apply the conjugate, which we are going to say the conjugate of this number is our 1 minus our I. So what you do at the bottom, you have to do it at the top, 1 minus I, like that, so that this divide by this, it is a 1, which was already there. Then we have minus y, then over our 2 minus I. Then we are going to introduce a conjugate, which will be our 2 plus I. Even on top, we have a 2 plus our I. So this one, we are going to apply the conjugate at the end for the denominator due to space. So we have 1 minus our 5i over our 3 minus our 2i, like that. So with this said, we are now going to apply. So x times this, it will be x times 1, it will be our x. X times I, it will be negative xi, like that. Then over, we are going to have 1 times 1. First number with the first number, it gives us 1. I times negative I, it will be negative I squared. Then we have minus, we have our y times 2, it will give us a minus 2y. Then y negative y times I, it will give us negative yi. Then over, we are going to have first number with first number, so we have 4. 2 times 2, it will give us 4. I times I, it will give us I squared. Now negative times positive it will be, so we have I squared. So this should be equal to, we have 1 minus our 5i, then over, we have our 3 minus 2i. After doing this, we are going to now be able to simplify if possible. So we have our x minus xi over, we have our 1. Then we know that I squared is equal to negative 1. Then we have minus our 2y. Then we have minus iy over, we have a 4 minus, we have negative 1 like that. Should be equal to, we have 1 minus our 5i, then over our 3 minus our 2i. Then what we are going to do is, we are going to apply the conjugate from here to remove it on the denominator. So we have our 3 plus our 2i, then even on top 3 plus our 2i like that. So after doing this, we can finally solve it. So we have our x minus xi over, this is 1, it will be 1 plus our 1. Then we have minus our 2y minus yi over, we have our 4, then we have plus 1 like that. So this should be equal to, we are going to multiply. This means that 1 multiplies everything here. So this is the same as 1 times our 3 plus our 2i. Then we have minus 5i multiplies everything. We have our 3 plus our 2i like that. Then we divide this by, if it's a conjugate, we are going to have 3 times 3. So first number with first number. So 3 times 3 gives us a 9. Then negative 2 times 2, we are going to have negative 4. Then I times I, it will give us I squared like that. So let us simplify our work. So we are going to have our x minus xi over 1 plus 1 gives us 2. Then we have minus our 2y minus iy over a 5 like that. So this should be equal to, we have 1 times 3, it will be 3. 1 times 2, it will be plus 2i. Then we have our negative 5 times 3, it will be negative 15i. Then we have our negative 5 times 2, we have our negative 10i squared. Since I times I is I squared over, we have our 9 minus 4. We know that I squared is equal to negative 1 like that. So simplifying some things, it will be equal to, we have our x minus xi over a 2 minus 2y minus iy over a 5. Then on top should be equal to, we are going to have our 3, then 2i minus 15i, it will be negative 13i. Then we also have our minus 10, this one is I squared, and I squared is negative 1 like that. Then over, we have our 9, then 4, negative 4 times negative 1, it will be plus a 4 like that. So with this done, we can be able to simplify further. So we have our x. Now here, what we are going to do is this. If you have, let's say, 1 over 2 plus our 3 over 2, this can be written as common denominator is 2. Then we have the top numbers 1 plus 3. So this means that if you have 1 plus 3 like this, they can be written back like that. So as long as the denominator is the same, things will always come out like this. So we can always go back to separate that. So that is what we are going to do. We are going to separate this. So this is the same as our x over 2 minus our xi over 2 as well. Then we have minus our 2y over our 5. Then we have minus yi over a 5 like that, which should be equal to, So we have on top, we have a 3 minus 13i. Then we have negative 10 times negative 1. It will be positive 10 like that, over our 9 over 9 plus 4 gives us a 13 like that. So what we are going to do after that is we are going to add. So we have our x over a 2. We are going to, the real part, we have to collect them. So without I, we put them together. So it will be minus a 2y over a 5 like that. Then we have our negative xi over a 2. Then we have minus yi over a 5 like that. Then we are going to have, this one should be equal to, so 3 plus 10, since they are like terms, this one gives us 13. Then we have minus 13i over our 13 like that. So after doing this, we can now be able to say this is our x over a 2 minus 2y. So we have over a 5, then we have minus xi over a 2, then minus our iy over 5. So this should be equal to, this can be split as 13 over our 13 minus 13i over our 13 like that. So this gives us a value of, we are going to have our x over, so here we are going now to equate them. So the real part, so we are going to say equating, we are going to have our x over a 2 minus 2y over 5. This should be equal to the real part, which is our 13 over 13. So when we divide, so we are going to have this one. So this can be simplified as we have our x over 2 minus our 2y, which should be equal to 13 over 13 gives us a 1. So this is the real part. So this one can be reduced to, let's make our 10 the common denominator between 5 and that. So 10 divided by 2 is 5 times 5. It will give us 5x here. Then 10 divided by 5, it will give us 2 times negative 2 there. It will just be our 4y like that, which should be equal to 1. So when we reach this stage, we are going to cross multiply. So when we cross multiply, we are going to have our 5x minus 4y, which should be equal to 10 times 1, which will give us 10. So this one is our equation 1, because we have x and y, meaning to say we need another equation which will come from the imaginary part. So the imaginary part, we are going to be having something like our, so we are going to have our, for this, for the imaginary part, so we have negative x. Now what you can do is, as long as the I is there throughout, you can cancel it, you cancel it, you cancel it. That is if it is there throughout. So we have a negative x over 2 minus y over 5 should be equal to negative 13 divided by 13 gives us negative 1. Then here also we are going to take our 10 to be the common denominator. So 10 divided by 2, that's 5 times x, it will give us negative 5x. 10 divided by 5 times 2, it will give us negative 2y, which should be equal to negative 1. So we are going to cross multiply. When we do that, we are going to have our negative 5, since 1 doesn't change anything, negative 5x minus 2y should be equal to negative 10 like that. So after we do that, we are going to collect the two equations. So our equation 1, which was our 5x minus 4y, then solve them simultaneously. So adding these two equations, we are going to have, so simultaneously adding this, so we have, since these are different signs, we can just add them direct. So this is the same as 5 minus 5. So we are going to have, it's more like it's a 0x, so we can cancel this. Then we have our negative 4 plus our negative 2. So this is the same as having negative 4 plus our negative 2, which should be equal to, we are going to subtract this. So we have a 10 plus a negative 10 like that. So we are going to have a negative 4y, here it is 2y, then minus our 2y should be equal to, we have a 10 minus 10. So we are going to have our negative 6y should be equal to a 0. So this means to say our y value should be equal to 0. So now getting any of the two equations, so our y is equal to the 0, then getting of any of the two equations, so we have our 5x minus 4y, so we have our 5x minus our 4y, this should be equal to a 10 as the equation says. So we are going to replace the y value, so we have 5x, then we have 4, where there is y we put 0 should be equal to 10. Then we have our 5x should be equal to 10. Then we divide by 5, we divide by 5. So our x value will be equal to 2. So that means that our y should be equal to 0 and our x should be equal to a 2. So let's look at our last problem. So it says that we have a 2p. So we have a 2p, then plus our 3iq, plus 1 over, we have 1 plus I. This should be equal to 2 plus I. Then we have a squared like that. So we are going to say this is 2p. Then we have plus 3iq. Then we have plus 1. So we are going to apply the conjugates to this number. So we have 1 plus I. Then open brackets 1 minus I. Even on top 1 minus I. So after doing that, we are going to say should be equal to this 2 plus I squared is the same as 2 plus I. Then we have our 2 plus I. It's more like the same number coming back twice. So we are going to have a 2p plus 3 iq. Then we have plus 1 times 1, it will give us 1. 1 times negative I, it will give us negative I, over. So we are going to multiply first number with first number. So 1 times 1, it gives us 1. Negative times positive, it will give us negative. I times I, it will be I squared, which should be equal to, this is the same as, let's expand this. So this is the same as 2. Remember, this is not a conjugate, so we have to expand. So the first number multiplies everything. So we have a 2 plus I. Then the second number multiplies everything again. So we have 2 plus our I there. So let us simplify. So this is the same as having 2p plus our 3iq. Then we have our plus 1 minus I. Then over, we have our 1 minus I squared is equal to negative 1. Then we have should be equal to 2 times 2, it will give us 4. 2 times I, it will give us plus 2i. Then we are here, I times 2, it will give us plus our 2i. Then we have our I times I there, it will give us I squared like that. So to simplify things, we are going to have first, we have 2p plus 3iq. Then we have plus 1 minus I over, this is 1, negative times negative, it will give us positive 1, should be equal to, so we have a 4. Then we have 2i plus 2i, it will give us 4i. Then we have our I squared is equal to negative 1. So we have plus negative 1. If we want, we can just put it direct. So we have, this is the same as negative I squared is negative 1 like that. So after doing this, we are going to now say this is our 2p plus our 3iq. Then we have plus 1 minus I over 1 plus 1 there gives us 2, should be equal to 4 minus 1, it gives us 3 plus our 4i like that. So after doing that, we are going to say let us separate this. So we are going to have our 2p plus our 3iq. Then we have plus 1 over 2 minus I over a 2, which should be equal to 3 plus our 4i. So collecting the like terms, the real part with the real part, we are going to have 2p plus 1 over 2. Then we have plus 3iq. then minus I over a 2 should be equal to 3 plus our 4i. So we are going to equate the real part with the real part. So we have a 2p plus half should be equal to, we are going to equate this to 3. Then the imaginary parts, the ones that has got I, we are going to say 3iq. Then we have minus I over 2 should be equal to 4i, like that. So when we do that, we are going to take the half this side. So we have our 2p should be equal to 3 minus 1 over a 2. So we have a 2p should be equal to 2 common denominator, then 2, it's more like it's 2 times this, it will give us a 6, 1 times 1 there, it will give us minus 1, like that. So we have a 2p should be equal to 6 minus 1 gives us 5, then we have over a 2. Then we are going to, what we are going to do is, we are going to make it simple, we need to cancel these 2, so we can multiply half throughout. Half times this one, we are going to cancel this. 1 over 2 times 5 over 2, this one will give us a p should be equal to 5 over a 4. So this is our p value. Then if we look at our q value, we are going to do the same. So since I is there throughout, we can cancel it. We cancel this, we cancel this, we cancel this, we cancel this. So we are going to remain with our 3q minus, if we cancel I there, it will be 1 over a 2, which should be equal to 4i, like that. Sorry, just 4. Then we are going to collect the like terms. So we have 3q should be equal to, we have a 4 plus 1 over a 2, like that. So when we add there, we are going to get, so here we are going to have our 3q should be equal to, we have our common denominator this side, we are going to have a 2 there. Then this is the same as multiplying 2 times this one, so 2 times 4 will give us 8, or if you can use the common denominator, it's okay. Then this one times this one, it will give us plus 1. So we are going to have our 3q should be equal to, we have a 9 over a 2. So after doing that, we are going to say, to get rid of the 3, we can just multiply 1 over a 3 throughout, so that 1 over 3 times 3 will cancel there. Then we are going to have, so this one is cancelled, then 1 over 3 times 9. So this is our q should be equal to 9 over a 2 times 1 over a 3. So we can reduce, so this, it's 1, 3 into 9, it's 3. So we are going to have our q value will be equal to 3 over 2. So this is how we solve complex numbers. Thank you very much for watching my video. Hope you would like, subscribe and share for more.